of interesting work both in the field of bilingualism that we'll talk about today. He also does things on embodied cognition, mathematical cognition, a long career. But today he's going to talk about bilingualism, brain, and cognitive performance, how they interact in a very nice two-part talk. So without further ado, I would just give the floor.
Thank you. Thank you, guys. First and foremost, for inviting me to tell you a little bit about the research that we do, because I use we, that actually is not just a decorative use of the pronoun. Most of the work has been done, and you will see it by the first authorship of most of the papers by Federico Gallo and other people. Most of this work were done A, in collaboration, and B, by people way smarter than me and way better than me at what they do. That's why I put all of them on the slide. You know many of these faces, some of them you don't. And of course, they're from all over the world, from Russia, Norway, Macau, UK, Denmark, other places. So they all contributed in very important and meaningful ways to the research that I'm going to be discussing today. These are the publications that went into the talk. So there's a total of 8 publications, and there's a promise. I think 90% of them are actually first authored by Federico, who did tremendous work under mine and Yuri Shtarov's supervision in Moscow, and continues to be a stellar postdoctoral fellow here in Lancaster and in Tromsø, from what I hear. Anyways, I will do a very simple and very common introduction to any bilingualism-related talk, and it is that bilinguals are everywhere. They used to be thought as a curiosity, something that diverges from the norm. Now they are the norm. We are the norm. Everybody here is bilingual, I'm sure. And this graph is from European data, where you see that in some countries, up to 99% of people are bilingual. Now, when it comes to Europe, most of the people who are bilingual would be bilingual by learning, like myself. So they went to school, they started learning a different language, and they developed capacity or proficiency in that foreign language, or several of them, to the degree that they can communicate in everyday life at home or abroad. In other countries, the situation is as diverse in terms of people speaking different languages. This is from India, and I gave a very much earlier version of this talk in Goa a couple of years ago. So where you see the darker colors in blue, that's the number of languages spoken in that area. So this extreme point is more than 75 languages. So here in Assam, for example, people speak up to 75 languages. So these people learn it from birth pretty much. They have to speak this many languages. This is a sign from Hyderabad. I took that picture. This is a sign in Hyderabad where you have to use all these languages in order for people to understand what the heck this sign means. The situation is not much different in China, where I started working in November 1st, which is 7 months ago. This is the situation in China. Again, different colors mark languages spoken in different areas. This picture was sent to me by a friend of mine who works at Polytechnic University in Hong Kong, and that's a sign in Hong Kong also, in various languages that are presumed to be spoken by people who live in the area. So it's very important to realize, before we talk about any cognitive consequences or neurocognitive consequences of bilingualism, that bilingualism now is a norm. It's a widespread norm, either by learning or by development. People speak in the globalized world speak more than one language. Some people speak 75 languages. Well, not all of them, but some people have to deal with a situation where there's dozens of languages spoken in the area. So, as I said, it's a simple introduction that suggests that something that used to be considered a curiosity now needs to be studied across the board, not only from linguistic perspective, but also from neurocognitive perspective, from societal perspective, intercultural perspective, et cetera, even from a medical perspective, as Professor Rotman told us, together with Dr. Gallo, told us today in the morning in a different talk. Right, so basically main conclusion from these 3 slides I showed you thus far is that bilingualism is a lifelong experience. You don't just switch it on or off. Once you use your language for communication, you use it all the time. And that leads to specific consequences, and far-reaching consequences at that. It is a lifelong, it requires a lifelong maintenance. What does that mean? It means that if you want to continue to stay proficient in any shape or form in your second, third, or 14th language, you need to maintain exposure, use, develop language skills. You do it either through formal education or social interaction. It also suggests that proficiency in L2 or LX is a dynamic property, right? Where it changes. It doesn't always stay flat. It's not like well, you achieve proficiency and it stays that way. Everybody who moved to another country or moved back from the country where you did your education, you know how quickly your proficiency can decline. So that balance is not a given, and it changes as I said. Shifts between you can go back to your L1 dominant, or you can switch back to L2 dominant. Now, finally, it is important from a societal viewpoint because bilingualism, first, language, first and foremost, is for communication, not for me to deliver lectures, not for you to understand what I'm saying, but to integrate in society, right? It goes well beyond being just a circumscribed medium for educational professional use. And for that, it changes your identity. If you are proficient bilingual, you live in a foreign country, everybody would attest to that, you become slightly different. And that identity is also not a given, it's also a dynamic property. So these are, and that goes on and on and on over your lifetime. It never stops. And that's very important because as a specific behavior of that type, actually not that specific, it's shared with other behaviors, it has several important questions. And two of them that are most important for the research we do, why I call bilingualism as multitasking. Right? Because if you speak one or two language, two or more languages, especially if you do it regularly, then you need to switch between them. Sometimes, like if you're a deaf child with a Russian parent and English parent, you need to do it all the time because you need to speak English to your daddy and you need to speak Russian to your mom, for example, right? And that leads to cross-linguistic interplay. That's a big question. What happens when your lexis, when your mental lexicon contains codes, lexical, phonological, orthographic, syntactic codes from different languages? You need to maintain them. You need to make sure that they don't jump in all of a sudden. They don't interfere with each other too much. Oh, hello. Can you hear me now? Are we good? Are we, sorry, those of you online, I'm sorry, I didn't know that my microphone was not, but you didn't miss much. Sure, sure, sure. I understand. Yeah, as long as they can hear me now, I'm very happy. Okay, okay, all right. Yes, so yeah, you all know that when you get tired or when you hungover, God forbid, these intrusions from your L1 are pretty much inevitable. All of a sudden, you say words that you're not supposed to say. That's because your control system, your executive function system, is under stress, and it fails to do exactly this: to monitor and make sure that you use the selected language efficiently. And that constant engagement of language control system leads to the long-term changes at the brain level, right? Because you need hardware to support this software performance or this functional performance. You need dedicated hardware at the brain level. And this is the topic of Freddy's talk today and Professor Wolfman's talk today. That leads arguably to the accumulation of neurocognitive reserve that helps you defend yourself, to defend your brain from cognitive decline during aging, right? So this is a nutshell, how the system, how the mechanism works. Today, I'm only going to be talking about the, come on, what's not working now? Is it muted now?
Oh, you're fine now. Yes, yes, now it should be fine.
Okay,
Now
okay.
you should click back on the slide,
Okay,
otherwise the thing will not see.
okay. Like that? Can they still hear me?
Yes, that's fine.
That's fine? Okay.
Sorry, sorry.
No problem at all.
They want to hear you.
Like I said, it happens all the time. I've never had a talk where there wouldn't be technical. Right. Other types of cognitive monitoring, conflict monitoring, or conflict control tests have also been used. Attention network test, or the version of it which is called flanker test, is very common, and I will tell you in a second how exactly it works. But more recently, in our lab as well, we started using more complex tasks where it's not just one aspect of visual input you need to control, but maybe several aspects of visual input, then including the content and memory. So we have a data set we're collecting now where we use a rather complex, actually several levels of complexity of visual search test, where you preload memory with the information and then you look at how that information affects searching for a target in the visual array. People have used other tasks that are more related. So these tasks are more related to attention and executive control. These tasks are related to working memory, including NBAC. That's a very popular task, but attention monitoring tasks as well. Okay, so as I said, I will be primarily using attention network tests today, with the exception of one study with NBAC. An attention network test was developed by Mike Posner and his colleagues in late 90s, and they developed it later to the most recent versions. But basically, in attention network test, you have three conditions. You have a lurking condition when there is no cue to the target, which is presented centrally, like this arrow, this arrow, this arrow, that's the target. You need to always indicate the directionality, electrical directionality of the target. Sometimes that target will be surrounded by no cue, and that's the alerting condition. You have orienting condition where the target is surrounded by flankers of the same direction, and you have conflict condition as the most important one, because you have more information pointing to the opposite direction to the one that the targets point into. And of course, you have more of that information. It takes inhibition system to get engaged in order for you to signal where the central target's looking, left or right. And the cause, so it's a very simple, kind of formula. You basically subtract reaction times from say alerting from conflict condition, you subtract alerting condition from that, and you get the cost, the reaction time cost, to how long it takes you to inhibit those surrounding flankers. So the first study I'm going to show you, so now you know what the test looks like. Of course, because we're interested in bilingualism as lifetime experience, we don't do group studies. So we don't compare the performance of our bilingual participants to monolingual participants, especially since there's no monolinguals, one would argue. And because it's interesting to look at the changes in cognitive system in response to bilingualism as individual difference level, right? So how it happens with dynamically increasing levels of bilingual proficiency. Also, because bilingualism is a very rich experience, we tend to collect data across different aspects of bilingual experience: exposure, proficiency measured both subjectively and objectively. In this study, we measured proficiency subjectively by a Q questionnaire, but also objectively, we created a bespoke translation task where Russian-speaking participants or L1 Russian participants had to find the correct match for this English word, right? So they see a display like that, and they need to know that that's the right word for this English equivalent, okay? So again, you can measure their accuracy, and you can measure the reaction time, the time it takes for them to select that correct translation. And of course, because other factors are known or have been known to affect cognitive performance, we control for things like social economic status and nonverbal intelligence score with, again, common suspects like SAS questionnaires and Raven's matrices. And so you collect all that, and then you look at how these different measures, some related to bilingualism, others not related to bilingualism, affect performance on this conflict effect, okay? Very simple. And what you find is this is the correlation between conflict RT cost in percentages and vocabulary error rate, right? So you see that the higher the vocabulary error rate, the higher the cost. So the better you know the language, in other words, the faster you are to resolve that conflict, the flanker conflict. Okay, so this is so good. These are young people. And the interesting thing about young people, they're of course at the peak of their cognitive performance. And because I told you at the beginning, or at least I tried to lure you into the logic of the talk by saying it helps you in senior years, it helps you when you're not as at peak of cognitive performance. We did another study where we took senior bilinguals, and that was done in Newcastle. So these senior bilinguals are 60 years or over, and they have different L1, L2 combinations compared to the first study that I showed you, which of course increases generalizability, but the rest is pretty much the same standard ANC protocol, measures of proficiency and use, and Raven's matrices. So the rest is the same, just to maintain simple logic here. And what we find is a very similar picture. So you pay attention to this. These are congruent trials, and nothing's happening there. But then in congruent trials, so we have two types of data here, both showing the same pattern. You see this improved flanker performance in senior bilinguals this time with longer L2 experience. This is years they've been speaking their second language. Mind you, again, these are different languages. You cannot just say there's something special going on about Russian-English pairing, right? And also you find the same thing to even make the story stronger when you look at their measured proficiency. So in first case, you could say this is exposure, how long they've been exposed to their L2. And in the second case, this is how well they can speak their L2. But the pattern, nevertheless, remains the same. The better you speak the language, the longer you speak your second language, regardless of what the second language is, the better your ability to resolve conflict as measured by flanker task. Okay, this so far so good. But cognitive performance comes in different shapes and forms. When we say cognitive performance, that's why I changed the title of my slide from cognition to cognitive performance, because cognition is way bigger. It includes affective processing. I'm not talking about affective processing today, but even if you talk about cognitive performance, it's not only the ability to inhibit what's trying to intrude into your flow of thoughts, if you want trains of thoughts, as James would say. But it also includes efficiency, how efficient you are. So with increasing demands of the cognitive task, how well are you to continue to maintain optimal performance, right? And that is typically addressed or often addressed by changing task difficulty, right? If I continue to maintain optimal performance or accurate performance with increasing task difficulty, that would indicate that I'm more efficient than you who can do the same thing. And it also indicates automaticity, where one would argue that bilingual experience via efficiency, so first via cognitive control practice, and then through cognitive efficiency would also affect the automaticity. How much resources do I need to allocate to the task to be able to perform it effectively? So in this third study, which just came out recently, we looked at exactly that thing, and we used then back tests with different degrees of difficulty from 0 to 3 and back with increase in difficulty. The rest is again very much similar. So we have objective, subjective proficiency measures, intelligence measures, and we look at two different outcome measures. One related to cognitive, well, actually two of them related to efficiency, and this is the performance decline measured as reaction time and measured as accuracy, or accuracy first, actually reaction time second, and also at automaticity. And that is indexed here via speed accuracy trade-off. And if you know anything about speed accuracy trade-off, it's typically, the pattern is typically the more you need more time to continue to be accurate with increasing difficulty, right? So that's why it's trade-off. You need to either stay accurate or continue to be faster. If you fast, you sacrifice accuracy. If you want to continue to be accurate, you increase reaction time. Now, because we assume that our hypothesize that our highly proficient bilinguals will be more efficient, we actually predict a reverse of that effect, that it will continue or even be better with increasing difficulty without sacrificing or compromising the reaction time, the speed of processing. And so first, accuracy. I will show you three types of data. So first, response accuracy, and what we see is indeed with higher L2 proficient bilinguals, it leads to higher accuracy under increased cognitive load, especially from 2 back to 3 back, and that's the most difficult shift in this task. And also this smoother performance decline. In fact, there is no performance decline with increasing difficulty of and-back task with proficient bilinguals maintaining accuracy more effectively, right? So they're able to withstand that pressure of increasing task difficulty and continue to perform accurately and continue to perform quickly. So on this slide, what you see, so especially pay attention to that graph, what the reverse happens. So higher proficiency bilinguals, and their performance was associated with reduced reaction times only and especially in the most difficult condition, which is exactly what we predicted to see. So you would expect when the task goes difficult, their performance should decline. But nevertheless, they actually become even better. So when I suggested to Freddy before, we should have titled that paper, "When going gets tough, the tough get going." You know, that's exactly what we see. So they perform best, it seems, on this task when it's difficult to perform well. And the same is true about speed accuracy trade-off. So you see the inversion of the effect exactly as we predicted. Instead of compromising speed and accuracy, they become better and faster with the increasing difficulty of the and-back task. Okay, now this is a very hot topic at the moment. I want to shift gear here. Okay, so we talked about their cognitive control is good at young age, at old age. Their efficiency is good. Their automaticity is good. The better you speak the language, you're better at all those things. But everybody's experience of using the second language is individual. Right? We all speak different to different audiences. Some primarily speak L2 in your family, to your spouse, to your child. Others, like myself, speak it mostly at work. Yet others use it when they travel, right? And so we all have idiosyncrasies in terms of how we use that, our L2. And when you think about individual differences that are related to the effect of bilingualism on cognitive performance, I would like to split them actually into 3 groups. But here I specified 2 groups. The third one being physiological differences. We may have problems with cardiovascular health or whatnot. We can't be deaf. So, for example, I have a new grant hopefully coming in where we will look at deaf people, or well, progressively that unilaterally deaf people, and how bilingualism helps them alleviate that problem. But let's leave aside the physiological differences. When you talk about linguistic differences, then one of the important difference in bilingual profiles is what is the second language that you speak? Like, so I speak four languages and two of them are very proximal. So Russian and Ukrainian are extremely proximal. Now, even if I didn't speak Ukrainian, I would be able to understand around 60% or 70% of what a Ukrainian is saying. And the other way around, by the way. Yeah, but of course, if you think about, say, English and Russian, they're way distant. Now, there's lots of questions how one measures sincere methodological challenges. I actually extracted that from the paper that you very kindly put online before it got published, where Jason and his colleagues did a very meticulous meta-analysis of linguistic distance studies. So in any case, so you can measure differently, and it's not certain, what exactly we're measuring by these different things, but I will show you the study that actually went into that meta-analysis, where we tried to use a very simple but indicative way of measuring linguistic distance, and that's the sort of genealogical or genetic linguistic distance measured as the separation in family or across families. Now, there's also second type of individual difference, and that's behavioral differences, right? So, for example, sleep. You would be like, well, what sleep has to do with bilingualism? Well, read the paper we just published in 2025 in Brain and Language, where we put the whole theoretical program forward together with this nice gentleman here, where we actually explain in detail why things like sleep need to be taken into account when you study bilingualism. Because we receive participants in the experiment, and we don't know how well they slept, or they jet lagged or not, but we do know from studies of our sleep scientist friends that sleep screws you up badly in terms of cognitive performance, right? And basically, you have counter forces this way. You have bilingualism that I showed you to be able to help you with that, and you have poor sleep on insomnia that does the opposite work, right? So they're actually natural friends to be put in the same experiment. So I'll show you two studies, one on linguistic distance, and you can actually come up with other factors like that. It doesn't have to be sleep. Sleep is just this showcase here, right? And you can use other factors, other behavioral factors that can be detrimental to your cognitive performance and pair them with bilingualism as well. So I'll give you a free project right there. Just write the grant into the study. Right. So this is a study from last year on linguistic distance, where, as I said, we measured it using a very similar genetic proximity calculator that is publicly available with 220 different languages. So you can take any pair and calculate the difference between them. Okay. Again, if you want to talk about this at the end, I can entertain your questions about this is a good measure, it's a bad measure. The good news is that in bottom line and top, it did work. So whatever that measures, it definitely measures something. And what we looked at here, again, the rest is the same. That's why I don't repeat the design. So it's flanker, you can see the flanker performance, and all sorts of measures that we need to take into account, like SES and rates. So what you see here is the modulatory effect of linguistic distance on contribution of bilingualism to flanker performance, with a more positive effect of higher linguistic distance languages at the beginning, meaning at lower levels of proximity. In the paper, we sell it as learning. I'm not so sure it's learning anymore. What we do know objectively, these are the people with lower level of proficiency. Some of them may be learning, others may be stupid. We don't know, but they're low, okay? So for them, it's good when the languages are very far apart. But for those who are good, who are highly proficient, it's better if the languages are proximal. And if you think about this logically, it's not surprising. Now, when you learn something, like if you learn to play a video game, it's not different than video game. If you learn to play a video game, you will learn faster if all your ships or whatever you're doing, tanks are far apart and you need to switch attention all the time, right? So what I would argue, that's not in the paper, I'm making it up a little bit, but what I argue, the effect of higher distance languages at lower proficiency levels is because you tax attention. That's attention effect more than cognitive control effect. Now, when you good at your L2 in your L2, yes, when you're highly proficient, then remember Weber's law. Did you do Introduction to Psychophysics? Weber's law. It's more difficult to inhibit two versions of the same stimuli if they are close together, right? Sound or light, doesn't matter. So the closer two stimuli are, the more difficult it is to inhibit one to respond to the other. So that's cognitive control. This, I think, actually, the higher distance, I think this is attentional orienting more than cognitive control. But very nice, well, one of the early demonstrations, I know there's more, but that's how individual differences in linguistic experience affect the general effect of bilingualism on cognitive performance, in this case, flanker performance. Now, I promised to talk about sleep. Same design, but now we also want to know how well our participants sleep. And for that, we used two types of questionnaires. So, no, one in this case. So we use PSQI. It's a very common self-reporting way of indicating how well you sleep, called Pittsburgh Sleep Quality Index. And you can then split participants or use it as a continuous variable in low score and high score, with low score being good sleepers and high score being bad sleepers. Now, first, quality check, because I was lucky enough to publish several papers on sleep and attention, because there's a good sleep lab in Newcastle, and I'm kind of good at attention, so it was natural pairing. So we published three papers on how sleep and sleep deprivation in particular affects attention. So we knew it should affect attention badly, right? So it should make it worse. And that's exactly what we see. So that's our sanity check. Good. And more importantly, of course, we wanted to look at how bilingualism and sleep quality interact in their capacity, joint and individual, to affect flanker performance. What we found is very interesting, and that prompted lots of discussions and further research. So the positive effect of bilingualism was pronounced for poor sleepers. Right? I'll just let it sink. Poor sleep. So if you sleep poorly, bilingualism helps. If you sleep well, you're okay. It doesn't matter. Mind you, these are young people. What did I say at the beginning? That young people are at cognitive peak. Now, what we did here effectively, we turned young people, well, they turned it themselves. We turned young people into old people, or they did themselves, because they don't want to sleep. Well, maybe they go night clubbing a lot. Yeah. But because we depleted that, we depleted that battery. So if you think about their cognitive performance resource as the battery, we depleted that battery a little bit, allowing bilingualism to produce its effect. And that, in many ways, I think this is a good demonstration of why bilingual advantage, what it used to be called effect, sometimes replicate, sometimes not. Partially, not fully. We argue because we don't measure these things. We don't measure things that may affect cognitive performance on top and beyond, outside of bilingualism. We lump them together. And here we show, if you deplete it, then you can see it in young people, because in young people particularly, it sometimes shows, sometimes doesn't. And it's a very good initial step to how to do these things, how to use other physiological and behavioral detrimental factors in order to bring out effects of bilingualism, especially in young population. So that's it about part one. And part two is shorter, so don't worry, I'll be there on time. I still have 20 minutes, or at least 15 with 5 minutes for questions. So what I hope I convinced you in is that the dynamic increase, individually dynamic increase in aspects of bilingual experience leads to or is associated with better cognitive performance in different aspects of cognitive performance, not just cognitive control. And that individual differences are extremely important. That's the next big step in the field, to treat bilingual experience as lifetime, and to treat bilingual experience among other lifetime experiences like sleep, like diet, like exercise, like stress, like anxiety, like depression, and I can continue forever, but I don't. So these individual differences matter because they allow us not to commit type 1 error all the time, and not to, what's it called, throw the baby with the wash water. So I invite you to do more of that after us, because we have grants submitted. It's important to get them. Okay, so the second part is what happens at the brain level because of this interesting interplay pattern between bilingualism and other individual differences. Because of course, as I said, for software functionality, you need hardware. Without hardware, there's no software functionality. Okay, so why should brain change because of this story? Well, because as any long-term experience, brain responds to new habits that continue to bombard the brain, if you want, continue to text the brain. It responds with these three things. It responds with functional dynamics. It responds with flexible patterns of allocating resources across networks. It responds to with the ability to switch between cognitive process more effectively, be more flexible, more effective, and it responds with neuroplasticity. Basically, you get more if you want. If you get more RAM, you get more memory to do with memory, not in human terms, but in computer terms, if you want, then in metaphoric terms. So it results in hardware changes. It results in gray and white matter changes. That's known about other things, not bilingualism per se, but any long-term behavior will change your brain that way. Now, does bilingualism do that? Well, we know from other people who came before us or together with us is that yes, indeed, it leads to, for example, when it comes to cognitive control, it leads to the formation or emergence of a dedicated control system that helps you avoid linguistic conflict. That control system is not modular per se. It's part of the general cognitive control system. It's just a new task that cognitive control system in general needs to perform. So you have on top of the general cognitive control network in the brain, you have a dedicated language control network. And we do know the nodes of the network, so they were again identified before us. So I will show you four studies, but very quickly. One kind of general, where we're poking around, and then more focused on specific brain regions. So this is the first study where we were, as I said, poking around. We actually had data, structural MRI data from a study that I already showed you. So a study where we did flanker performance in young bilinguals, and which just looked very broadly at some executive control related areas and some language related areas, and that's what we found. So we did find changes in BBM and volume-based morphometry in several executive control related areas and in at least two left use form charts in BA20, visual word form area, in language related areas. But this, like I said, this was exploratory analysis. We didn't aim at these particular regions. But because we were quite enthusiastic after that and quite optimistic, we did more focused studies. And the last three studies I'll show you today do exactly that. We targeted those regions in the brain that have been shown by others to be important hubs in language control network. And I will start with arguably what is the hub of the network, and that's caudate nucleus. But the rest is the same, and we extracted gray matter volumes from several structures that, as I said, have been implicated in language control and executive functions. And these three structures include caudate, hippocampus, and cerebellum. It will be easy to do the rest because the pattern is relatively the same except cerebellum. But so these are the structures. If you are not familiar with your anatomy, that's where they are. This is caudate, bilateral, this is hippocampus, and that's cerebellum. Okay. I will bring them back together in the last slide. So again, setup is the same. We're doing the same T thing, and we're also measuring changes, dynamic changes. It's a cross-sectional study, of course. But here, what you see is bilingual index from mean. So this means they're low proficiency. This means they're high plus two standard deviations. They're high proficiency people. What the interesting thing you see when it comes to coding is as you get better in your L2, as you probably would predict and expect me to say, the volume of coding grows up to the maintenance point. So let's say this is learning, and you learning your language, you don't speak it well. That's where you know, okay, I can speak it finally. All right, and then you get better. But look what happens. So the brain volume actually goes down. Now, I will give you a very nice graph that actually fairly designed that shows what's happening. So what happens here, the best way to understand that, if you ever went to the gym when you just started, right? So you start doing weights, you start pulling weights, your muscles, what they do? They grow, right? You grow muscle. But then if you continue to do that, especially like, for example, if you're running, if you continue to tax in your organ, in your body, right? You start losing weight. You maintain muscles that are effective, but you lose the muscle growth stops, but the efficiency continues to grow. So the performance efficiency here continues to grow, but the corresponding machinery gets reorganized in a similar way, like you would get your muscles reorganized to maintain performance in physical exercise. And as I said, it's going to be easy to get to the wrap-up point because we found the very similar, pretty much exactly the same pattern in hippocampus, right? The most recent paper, we're still writing it, so this is the most recent data, and that's on cerebellum. What we see here is a linear increase in with greater L2 exposure. You have a linear increase in the cerebellum, and that region is of course linked. And I get this question all the time, but that is linked to so many things. Yes, it is, and we don't know exactly what in bilingualism changes. No, what and why from bilingualism changes the volume of cerebellum, because cerebellum, coordinates your behavior, even coordinates, syntactic performance, speech rate. So that's an open question, and as I said, we just started, so we would be very happy to continue to entertain these questions. Um, Yes, so all put together, it suggests that bilingualism enhances the volume and the resilience or the performance of cerebral resources in order to maintain efficient cognitive control and cognitive performance in general. So this is, as I promised, this is the wrap-up slide before I do final conclusions. Good time, Andrei. That is exactly how efficiency, if you go back to, oops, it's wrong way. Yeah, if you go here, this pattern, the inverted U pattern, is summarized here, where you have efficiency that continues to linearly increase, and that's your behavior, right? And the U-shaped function that is projected onto this that exemplifies how the brain responds to the first increase in the demand, and then by increasing GMV, and then by pruning, by only remaining the most efficient connections and releasing the other connections to do whatever else needs done. And that is that's the combined language control network. So as I said, we looked at cerebellum, body, and hippocampus, but there's of course more to study. So finally, let me wrap it up with general discussion. I think in this 40 minutes or so many that I used today, I tried to convince you that bilingual experience is rich, and the increase in the richness of bilingual experience leads to improved cognitive performance. And that improved cognitive performance, changes in cognitive performance are individual in the sense that you need to take into account specific bilingual profiles of the individuals that we study, both from the linguistic viewpoint and from behavioral and physiological viewpoint. Finally, this complex interplay leads or results in plasticity in cortical areas associated with some linguistic processes, but also with general processes like cognitive control and cognitive efficiency, and that is modulated by individually measured bilingual experience. So with that, this is it from me. Thank you very much. If you need to contact me, that's where you find me, and I will be happy to share the slides and answer your questions if you have any. Thanks very much. Oh, please.
You say like you play video games and speaking two languages are similar things. Training to like switch tasks.
I didn't say they're similar things. I use a map.
Oh, it's as good as they get. Just wondering, in your opinion, is there anything about speaking two languages? Is there anything special about speaking two languages compared to training on some other things that could give you similar kind of transfer?
It's an excellent question, and there's very little which maybe Jason will have me, and he knows much